So public key infrastructure is the process of generating public and private keys on multiple devices and then registering our public key with a central entity called the certificate authority. And what we basically do is let's just jump over to a whiteboard real quick. And let's say that here I am with my laptop. I can use a utility called PuttyGen, or you can use OpenSSL or lots of other things to generate an RSA key pair. And you can use DSA if you prefer. That gives me a public and private key. This is enough to do asymmetric encryption, but it's a bit cumbersome to do it with lots of people. There's a lot of phone calls, there's verification, the update process is complex. It could be pretty nasty. So what we do is we'll take our public key, and then we'll take information that makes this key relevant. Now, it might be a fully qualified domain name, it might be your email address, but we're going to tie in real-world information, practical things that are tangible, and associate them with that public key. And this is called a certificate signing request, or CSR. We send that certificate signing request to a certificate authority, and the certificate authority has an administrator, and his job, or her job, is to verify all of this information. And if that information looks valid, they'll go ahead and they'll grant a certificate. So when we hear the term X.509 version 3, this is just a standardized version of our public key. And we take information about us, and we associate it with that public key, or the router, or whatever this key belongs to, or the server. And then the certificate authority, maybe it's VeriSign or Entrust, they're going to include their information. And then the certificate itself has got some details. There's going to be an issue date, an expiration date, a serial number that we can use for revocation, a revocation list distribution point. So you can go get a list of all the certificates that have been thrown away. All this information goes into a document called an X.509 version 3 digital certificate. What does it hold that's important? Your public key. But it's just a way to give your public key to other people, and it's a way that they understand. It doesn't matter if it's Windows, Linux, OS X, FreeBSD, everybody does this the same way. That's the beautiful thing about standards. So the idea here is that you've got two parties, user A and user C. They would both have to generate keys. They'd have to create certificate signing requests. They'd have to talk to the certificate authority. They'd be issued their certificates. But once their certificates are issued, A and C can communicate and they can identify each other all day, every day, without really having to interact with the certificate authority a whole lot. It's just like if you or I were to meet in an airport. Maybe I'm flying through, I'd go through Phoenix, and you go, Ryan Linfield, is that you? I go, yeah, that's me. And you go, are you sure? I'm like, yeah, look, it's my ID. And you go, oh, it's a state-issued ID, I guess that is you. And then I would ask who you are, and I'm like, are you trolling me? And you say, no, look, it's my real ID. And I would look for the hologram, and there's a kind of a format. It doesn't matter what state you're from, we all kind of do it a very similar way. So I always think of a public key infrastructure kind of like the Department of Motor Vehicles. You knew how to drive before you got there. You had an address, you had a height, an eye color, things like this. But you just went and you made it formalized. You proved that you were who you said you were. And then you can use that ID to authenticate to other people. So when the CA generates this digital certificate, I told you that there's a bit of information there. Got your public key, you've got information about you, you've got the CA server, you've got the certificate. That's all great. Let's take that information and hash it. That gives us a digest. Now we can take that digest and we can encrypt it using the CA server's private key. This is the private key of the CA, and it's being used to encrypt the hash. Who can decrypt that? Anybody with the public key of the certificate authority. So when we say that a certificate authority is a trusted root, we say that we believe the certificates that they issue. So whenever they issue a certificate, here's all the details that goes into X.509, but the last step is that digital signature. We talked about that in an earlier section, just wanted to readdress it here. That hash, once it's been encrypted with the private key, will be a digital sig, and anybody with the CA server's public key can validate that. So they know that you are who you say you are. It's kind of like if I looked at your ID and I wiggled it back and forth and I looked for that hologram to light up. So whenever we have a signed public key, this is just called an identity certificate. These are going to be returned to the entities. So again, you send in your certificate signing request to the CA server, they validate the information, and they issue a certificate. You take that certificate and you'll use it to identify yourself whenever you talk to other parties.